Hello friends, today we'll discuss the high voltage engineering's next topic, that is a mechanism of the breakdown in the solid dielectric. The breakdown in the solid dielectrics happens in such a way. The solid insulating materials are used almost in all electrical equipments, be it in electric heater or a generator or a circuit breaker. A solid insulation forms an integral part of all electrical equipment, especially when the operating voltage is high for power transformer and the devices which are used at a high voltage level. The gas and solid dielectric cannot be used for some reasons. Hence, the solid dielectrics will be used there because gas and liquid dielectrics will fail there. The solid insulation not only provide the insulation to the live parts of the equipment from the grounded structure, it also sometimes provide the mechanical support to the equipment. Means it serves two purposes. One is for the insulation, other it can provide the mechanical strength to the equipment. The processes responsible for the breakdown of the gases, the electric, are governed by the rapid growth of the current due to the emission of electron from the cathode, ionization of the gas particles, and the fast development of the avalanche process, primary and secondary, as given by the Townsend criteria. When a breakdown occurs, in case of gas, they regain their dielectric strength very fastly. The liquid dielectric regain partially, whereas in case for the solid dielectric, they lose their dielectric strength completely. Means they cannot be used for the next time if there is a breakdown in the dielectric of the solid. The breakdown of the solid dielectrics not only depends upon the magnitude of the voltage applied, but also it is a function of the time for which voltage is applied when we are applying the voltage. The product of breakdown voltage and the log of the time required to break down is almost constant. This is given by this equation. VB is given by the ln of the TB. TB is the breakdown time. The product of both is constant. The characteristic is given by this figure, that is 1.14. Here that is a breakdown and this is a time. The same is like this is intrinsic or electromechanical, then avalanche, then thermal, then erosion or electrochemical. This is a different kind of the breakdown that occurs. The dielectric strength of solid materials is affected by many factors like ambient temperature, humidity, duration of the test, impurities, or structural defects, whether AC or DC or impulse voltage are being used, uh, pressure applied to these electrodes. All the factors which we have discussed above will affect the breakdown of the solid dielectric. The mechanism of breakdown in the solid is again less understood as for the liquid dielectrics. However, as said earlier, the time of application plays an important role in the breakdown process. For the discussion purpose, it is convenient to divide the time scale of the voltage application into the regions in which different mechanisms operate, like intrinsic electromechanical, then avalanche, then thermal, then erosion, and electrochemical. At a very starting, there is increasing or electromechanical, then as time passes avalanche, then thermal, then finally there is erosion or electrochemical. That is the time on the basis on which the breakdown in the solid directly will occur. Also, for the intrinsic or electrochemical, the voltage breakdown voltage will be very higher. Further, the various mechanism of breakdown in the solid dielectric can be divided into four major parts. First is the intrinsic breakdown. Second is the electromechanical breakdown. Third is a breakdown due to the tearing or tracking. And the last one is a thermal breakdown. All the different breakdowns will be discussed in detail in the next lecture. Thank you.